Hi guys, today I'm gonna discuss about energy. So, first energy, electric energy. Electrical energy is energy newly derived from electrical potential energy when loosely used to describe energy absorbed or delivered by an electrical circuit. For example, one provided by an electric power utility. Electrical energy refers to energy which has been converted from electrical potential energy. This energy is supplied by the combination of electric current and electrical potential that is delivered by the circuit. Example of an electrical energy. Next is radiant energy. Radiant energy is the energy of electromagnetic waves. That quantity of radiant energy may be calculated by integrating radiant flux or power with respect to time, and like all forms of energy, its SI unit is the joule. The term is used to particularly when radiation is emitted by a source into the surrounding environments. Radiant energy may be visible or invisible to the human eye. Radiant energy is used for radiant heating. It can be generated electrically by infrared lamps or can be absorbed from sunlight and used to heat water. The heat energy is emitted from a warm element, floor, wall, overhead panel, and warms people and other objects in room rather than directly heating the air. Because of this, the air temperature may be lower than in a conventionally heated building, even though the room appears just as comfortable. Various other applications of radiant energy have been devised. These include treatment and inspection, separating and sorting, medium of control, medium of communication. Many of these involve a source of radiant energy and a detector that responds to the radiation and provides a signal representing some characteristic of the radiation. This is the example of a radiant energy. Next is thermal energy. Thermal energy is the portion of the thermodynamic or internal energy of a system that is responsible for the temperature of the system. The thermal energy of a system scales with its size and is therefore an extensive property. It is not a state function of the system unless the system has been constructed so that all changes in internal energy are due to all change in thermal energy. As a result of heat transfer not work. Otherwise, thermal energy is dependent on the way or method by which the system attained its temperature. Example of thermal energy. An example of thermal energy is boiling water in a pot. Thermal energy is the kinetic energy of the progression of atoms and molecules. It is caused by the enhanced activity or velocity of molecules in a matter, which in turn causes temperature rise. So next is sound energy. Form of energy associated with the vibration or disturbance of matter. Sound is a mechanical wave and as such requires a medium to travel through. The sound energy is in a volume of interest is defined as the sum of the potential and kinetic energy densities integrated over the volume, with the volume or region of three space of interest, sound pressure, particle velocity, density of the medium without sound present, local density of the medium, sound speed. And next is chemical energy. In chemistry, chemical energy is the potential of chemical substance to undergo a transformation through a chemical reaction or to transform other chemical substances. Examples include battery and light bulbs and cells, etc. Breaking or making of chemical bonds involves energy, which may be either absorbed or evolved from a chemical system. Next is nuclear energy. Nuclear energy usually means the part of energy of an atomic nucleus which can be released by fusion or fission or radioactive decay. Nuclear energy may also refer to nuclear binding energy, the energy required to split a nucleus of an atom. Nuclear energy or sculpture, a bronze sculpture by Henry Moore in the University of Chicago. Nuclear potential energy, the potential energy of the particles inside the atomic nucleus. Nuclear power, the use of sustained nuclear fission to generate heat and electricity. And last is nuclear technology, application of nuclear energy including nuclear power, nuclear, and nuclear weapons. Renewable energy. Renewable energy is generally defined as energy that comes from resources which are naturally replenished on a human timescale such as sunlight, wind, rain, tides, waves, and geothermal heat. Renewable energy replaces conventional fuels in four distinct areas: electricity, generation, hot water, space heating, motor fuels, and rural off-grid energy services. About 16% of global final energy consumption presently comes from renewable resources, with 10% of all energy from traditional biomass, mainly used for heating, and 3.4% from hydroelectricity. Kinds of renewable energy. Renewable energy, biofuel, biomass, ethanol fuel, geothermal, hydropower, solar energy, tidal power, wave power, wind power. Topics by country. Non-renewable energy. A non-renewable, also known as an finite resource, is a resource that does not renew itself at a sufficient rate for sustainable economic extraction in meaningful human time frames. An example is carbon-based, organical derived fuel. The original organic material with the aid of heat and pressure becomes a fuel such oil or gas. Fossil with the aid, fossil fuels such as coal, petroleum, and natural gas, and certain aquifers are all non-renewable resources. Metal ores are other example of non-renewable resources. The metal themselves are represented in a vast amount in the earth crust and are continually concentrated and replenished over millions of years. However, their extraction by humans only occurs where they are concentrated by natural processes such as heat, pressure, organic activity, weathering, and other processes, and not to become economically viable to extract. Fossil fuel. Natural resources such as coal, petroleum, crude oil are naturally take thousands of years to form naturally uh, and cannot be replaced as fast as they are being consumed. Eventually, it is considered that a fossil-based resources will become too costly, harvest, and humanity will need to shift its reliance to other sources of energy. These resources are yet to be named. The law of conservation of energy. The law of conservation of energy is a system may take on various forms: kinetic potential, heat, light. The law of conservation of energy states that energy may neither be created nor destroyed. Therefore, the sum of all energies in the system is constant. In physics, the law of conservation of energy states that the total energy of an isolated system cannot change. It is said to be conserved over time. Energy can be neither created nor destroyed by change form. For instance, chemical energy can be converted to kinetic energy in the explosion of a stick of dynamite. A consequence of the law of conservation of energy is that a perpetual motion machine of the first kind cannot exist. That is to say, no system without an eternal energy supply can deliver an unlimited amount of energy to its surrounding. So guys, that is it. Thanks for watching, and I hope it helps you. Bye!